So when you think about Earth history and about the diversification of minerals, you have to start from the very beginning, what we call the minerals, the founding minerals. And these occurred long before Earth, long before there were any planets. In fact, they occurred in the very first few million years of the cosmos in exploding stars. You see, you have to think, what is a mineral? A mineral is a crystalline compound that has a very fixed set of chemical compositions. So, when could a crystalline compound have formed? They can't be at too high temperature. So right after the Big Bang, you had helium, you had hydrogen. Those are gases. They're not going to form crystals. So you had to form the first stars. And those stars, through nuclear processes, started generating more and more chemical elements. Carbon, oxygen, nitrogen, silicon, magnesium, calcium, the major rock-forming elements. But of course, they're still locked in that star. They're too hot. There's no minerals because it's too hot. So you have to wait till the star changes. And it can change in a couple ways. In some kinds of stars, very energetic stars, pulses of energy cause envelopes of gas to be burst out into space. And that gas can contain those other elements and can cool. But even more dramatically, the supernova, when the entire star explodes and releases all of those chemical elements into the cosmos. And when it does that, that gas expands, it cools, and when a carbon-rich part of that star cools to below 4,000 degrees above absolute zero, diamond forms. Diamond is the first mineral in the cosmos because it has a fixed chemical composition of a very common element in stars, carbon, and it has a very, very high temperature at which it first crystallizes. Then you cool 400 degrees more to 3,600 degrees above absolute zero, and graphite forms. The mineral that you find in your pencil, that's graphite, another pure form of carbon. And then there are a number of others, about a dozen in all, the minerals. So those minerals make up the dust and gas that surround the proto-sun as our solar system is forming. The sun is forming. 99% of the dust and gas come into the center. Gravity starts squeezing and heating, and then you get bursts of energy that radiate throughout the disk. The disk that's forming that has the leftover dust and gas that didn't go into the sun. And those bursts of heat start melting particles of dust. Little, if you can imagine little dust bunnies in space. Well, they melt, and then they form little droplets called chondrules, and those droplets stick together, and you have the earliest meteorites called the primitive chondrite meteorites. They have about 60 different minerals because what you've done is you've taken the original 12 and you've heated them and you've processed them and you've melted them and you recrystallized them, and so you now have 60 minerals, 12 to 60. And then those chondrites, they come together, they form larger and larger bodies, planetesimals, things that are 50, 100 miles across. And when you get to that size, they're large enough to melt inside. And so the metal sinks to the center to form a nickel-iron core. Other minerals form a mantle on the outside. And all these processes, plus the fact that water interacts and alters those rocks and minerals, and heat metamorphoses them, and you have impacts where two planetesimals collide together and forming shock minerals. You get up to 250, 12 to 60 to 250. And that's what makes planets.